This is Jeremy Clark of JeremyBytes.com, and today we're going to continue our look at C# delegates. This time, we're going to be getting a little funky. We're going to look at one of the built-in delegate types, Func-y, and we'll also see how Lambda expressions fit into the picture of delegates as well. Now, just as a quick review, a delegate is a type that defines a method signature. This means that instead of defining data and method implementations like most of our other types, this just defines the method signature, so the parameters and the return type for a particular method. Now, why do we care about delegates? Well, as we saw last time, they allow us to decouple our code. This can give us extension points into classes without having to modify the classes themselves. And we can use methods as parameters. Again, this is known as a higher order function, a function that takes another function as a parameter. In addition, delegates have multicast capabilities, so we can run more than one method by invoking a single delegate. And we can use them in callbacks and event handlers, and we see them frequently in LINQ. Now today we're going to take a little bit of a detour to show how we can use the built-in delegate type Func-y, and we'll also see how Lambda expressions fit in with delegates. So let's jump over to the code. So as a reminder, let's look at how we left our application. If we run our application, we see we have a list of person on the left-hand side. Then in the middle, we have some string handling options, and then we have a process data button. And when we click process data, we'll see our output box shows whatever string handling method we chose. So our default value is first name space last name. Our last name is last name to uppercase. First name does first name to lowercase. And full name does last name comma first name. And again, these decisions can be made at runtime because we have a delegate inside of our person class. So as a reminder of what we have here, we do have a custom delegate type that we created called personFormat. And this declares a method that takes a person as a parameter and returns a string. And we actually use this delegate type as a parameter inside a toString method on our person class. So this allows us to inject any method that we want as long as it takes a person as a parameter and returns a string as a result. By doing this, we can change the functionality of our person class without having to modify the class itself. And then back in our code behind, we see how we select our different methods. So at the top of our class, we have a personFormat variable called formatPerson. And then our assigned delegate method will assign a particular method to our variable based on which radio button's checked. And as our last step, we loop through all of our person objects in our list, we call toString on them, and we pass in our formatPerson variable. Now this is all well and good, but there's actually an easier way that we can do this. Starting with .NET 3.5, we got some built-in delegate types. One of those is Func-y, so let's go to help and look that up. And so here we are looking at Func-y tResult. Now this isn't anything special. All it is a predefined delegate types that uses generic type parameters. If you want more information on generic type parameters, I do have another video series on C# generics. Now Func-y tResult is pretty easy to parse. So tResult is actually the type of our return value, and t is the type for our parameter that's coming in. And to show how this relates to our custom type, let's put them side by side. So here's our custom one, public delegate string personFormat, person input. So if we put in the definition for our Func-y tResult, we have public delegate tResult, func of in t, out tResult, and then targ. So let's go ahead and move these around a little bit so that our parameters and types line up. So we see the declaration of func is very close to our declaration for personFormat. Instead of string as the return value, we have a generic type tResult. And instead of person as a parameter, we have a generic type t. Now because func uses generics, that means that we can substitute this with whatever types that we need. And that means we don't actually have to create this custom type. So rather than using the custom type, we can just use func instead. So let's go down to our toString method, and instead of using personFormat, we'll say func and we'll use this overload that takes one parameter. So our parameter type is person, and our return type is string. So what we have now is a delegate that matches the same signature that we had before. So it takes a person as a parameter and returns a string as a result. But instead of creating a custom type, we can just use the built-in func type that we have in .NET. So now that we've changed our code, we'll need to make some modifications to our code behind in our class. Now this person format type no longer exists, but we can create a variable of type func of person string called format person, and everything else stays exactly the same. We have the same method signature. We're taking a person as a parameter and returning a string. That means the assignments of all of the methods that we have before still work, and we don't need to make any other changes to our code. And if we run our application, we'll see that it works exactly the same way. So we have our default, we have our last name to upper, our first name to lower, and our last name comma first name. So we haven't changed functionality at all. Now, why should we use func over creating a custom delegate type? Well, first of all, because it's there. If I can avoid creating a custom type and I can use one that's already in the box, then I want to use that. But more importantly, I really like using func because it gives us all of the information that we need. So let's go down to our toString method. Now, if we ask for help of what the type is for this, previously we had something that just said person format. Well, that doesn't tell me anything about the type, and I probably need to click over back to the person class, look at what this person format type is. Oh, it's a delegate that takes a person and returns a string. But now that we have func in here, I have all of the information I need right here. Okay, so this is a func of person string. That means it takes a person as a parameter and returns a string. And this makes it much, much easier to figure out what I need to use as a parameter for this method. Now, there are some subtler reasons we don't want to use custom types as well. If we create two different custom types, even if the method signature matches, they're still different types, so we're not able to assign one to the other without doing some additional code. But when we're dealing with func of person string, anything that matches this signature is assignable to this format person variable. And at the same time, any method that matches this signature can be used as a parameter for our toString method. Now you might ask, what if we have more parameters? Well, if we go back to our help file, we'll see there is also a func of t1, t2 result. So this takes two parameters and returns a value. In .NET 3.5, we got t1, t2, t3, t4 t result. So we could have up to 4 parameters. Now, I guess someone decided that 4 parameters wasn't enough because in .NET 4.0, we got this one. Yes, this actually defines a method that takes 16 parameters. Now, I was really hoping that in .NET 4.5, we'd get one that would take 64 parameters, but I guess that didn't happen. Now, if you do find yourself creating a method that has 16 parameters, you might want to ask a friend to take a look at it, but we do have that option available. So, func will take between 1 and 16 parameters, and there is actually a func that doesn't take any parameters at all. It just has a return value. Now, anyone who knows me knows that I really love Lambda expressions, and wherever I see func in my code, I treat that as a big flashing sign that says, put your Lambda expression here. Now, a Lambda expression is simply an anonymous delegate, which means wherever we see func, we can replace it with a Lambda expression. Now, if you want some more information on the anatomy of a Lambda expression, I do have a video on my channel called Anatomy of a Lambda Expression. Here we'll just go through the short version. Now, what we have now are known as named delegates. So, for example, in our Option 1 button section, we have a named delegate called formatters.default that we assign to that format person variable. Now, if we click into formatters.default, we see that it's simply a method that conforms to our signature. So it takes a person as a parameter and it returns a string value. Now, rather than using a named delegate, we can convert this into an anonymous delegate. Well, what's an anonymous delegate? It's simply a delegate without a name. Let me show you how we can do that. So I'm going to take the parameters and the method body, highlight that and say Control-C to copy, and then we'll go back over to our code, and instead of assigning to this formatters.default, I'm going to use the delegate keyword and then paste. So you can see I have the delegate keyword, then our parameter, which is person input, and then the method body inside the curly braces. And I can actually do this with the rest of our delegates as well. So we'll take last name to upper, come back here, we'll use the delegate keyword and paste. And then here's first name to lower, and then the delegate keyword and paste. And then finally we have the full name. So we'll just copy this over, use the delegate keyword, and paste. So what we've just done is inline all of our methods. And just to show that we don't need our other methods anymore, I'm going to comment out this entire class. So I'm just going to say Control-KC to comment that out. And now when we rerun our application, we'll see that it still works exactly the same way it did before. So we have our default, our last name to upper, our first name to lower, and our last name comma first name. So we haven't affected the functionality at all. Now I mentioned that a Lambda expression is simply an anonymous delegate. Well, we have anonymous delegates here. So let's change them to Lambda expressions. All we have to do to change a delegate to a Lambda expression is remove the delegate keyword and then put the Lambda operator in between the parameters and the method body. And again, the Lambda operator is just this funky equal greater than sign. So we'll add that to all of our methods. And now we have Lambda expressions. And as you might expect, our application works exactly the same way that it did before. So we can see that all of our values are still coming out as expected. Now, Lambda expressions have the advantage of having some syntactic sugar that we can use to make them very, very compact. Now, the first thing is known as parameter type inference. What that means is that if the compiler can figure out the type of the parameter, we don't have to type it in. So I can remove this person keyword from our parameters. Now, if we hover over input, we see that it is still strongly typed. So it is still of type person. Now, the reason the compiler can figure this out is because this is the only thing we're allowed to assign to our format person variable. Again, what is our format person? Well, it's a func of person string, which means it does have to take a person as a parameter. If we tried to assign anything else, we'd get an error. Now, another thing about Lambda expressions is if we have a single parameter, we don't need parentheses around it. So we can just have input just like this. Now, as a convention, people generally use single character parameter names for Lambda expressions. So we can change the input to just P, and that will stand for person. And to make things more compact, because we have an expression lambda which returns a value, we actually don't need the return keyword, and we don't need these curly braces either. So I can actually delete all of this. Now what we're left with is P, our parameter. And again, this is strongly typed. It is of type person. And then we have our lambda operator. And then we say p.toString, calling our default toString method. So we can see that Lambda expressions can make things very, very compact. Let's do this with our next method. And again, I'll take this one step by step. So we can remove the person keyword because our compiler can figure this out. We can remove the parentheses since we only have one parameter. We can rename our parameter to a single character. And again, that's just a convention. It's not required. And then we can remove the curly braces and the return statement. So if we do this with all of our methods, we come up with something extremely compact. And just to show you that this still works the same way, let's run our application, and we'll see we have our default, our last name to upper, our first name to lower, and our full name, our last name comma first name. So this is why I think Lambda expressions are really, really cool. In this case, before we switched over to Lambdas, our first option was assigning format person to formatters.default. That meant that we had to go to an entirely different class to see what that method actually does. And these methods are very simple. They're all just one-liners. Instead of going to a separate class, now all of these methods are in line, and the code is very compact, and we can see exactly what's going on. So for our second option, we're taking the last name property and converting it to uppercase. For a third option, we're taking the first name, converting it to lowercase. And for the last option, we're doing a string.format to get last name, comma, first name. Now, I am a huge fan of Lambda expressions and also LINQ, so you might want to take a look at my website, and I have a presentation called Learn to Love Lambdas, which dives into this a bit more. So what we've seen today is that rather than creating a custom delegate type called person format like we had before, we can simply use the built-in func of t result as our type and fill in the generic types that we want. So if we want a method that takes a person as a parameter and returns a string, we can just say func of person string, and we don't have to modify any of the other calling code. Now back in our class, we did have to modify our variable. So instead of our format person being of type person format, it's now of type func of person string. And again, I really like having that here because this tells me exactly what format person is. It needs to represent a method that takes a person as a parameter and returns a string result. And we saw how we could swap out our delegates for Lambda expressions. Now, a Lambda expression is simply an anonymous delegate. So if we take our named delegate and inline it, that creates an anonymous delegate. And then we can switch over to the Lambda expression and take advantage of a lot of the syntactic sugar to make very compact code. So instead of having to have a separate formatters class with all of the methods in it, I just have all of the methods in line in a very easy to read format. Now I know some people debate the easy to read part of that, but I encourage people to get familiar with Lambda expressions and learn to love them because they are extremely useful. So today we were able to get a little funky. We saw how we could use the built-in delegate type func of t result rather than having our custom delegate type. And we saw that func provides for a varying amount of parameters, so we can have between 0 and 16 parameters and still use this built-in delegate type. And since Lambda expressions are simply anonymous delegates, that means we can swap in Lambda expressions wherever we're using func. Again, when I see func declared somewhere in the code, I treat that as a big flashing sign. Put your Lambda expression here. To get more information and to download the code samples, feel free to head over to www.JeremyBytes.com, and we'll see you next time.